Hi everybody, in this video I'm going to be walking you through how to do geometric formulas with pyramids. This is for Project Lead the Way Intro to Engineering Design, and we are in lesson 5.4 calculating properties of solids. So first let's start off with what is a pyramid. Okay, so a pyramid is actually a geometric shape that is created whenever we connect some kind of polygon, like in this case there's a base that's a rectangular shape or perhaps even a square, and it's connected to a point. And you'll notice that really what it is, it's a series of squares that are stacked on top of each other, but the squares get smaller as they go along. Okay, so it's almost like similar shapes kind of stuff. But when it connects to that apex, that's what forms a pyramid. And I think the thing that's maybe confusing to a lot of the students that I have is there are actually lots of different kinds of pyramids. And so you'll see, look at the names that we have here, right? A rectangular pyramid, a hexagonal pyramid, heptagonal, decigonal. Really what it's doing is it's saying in each of these cases, the name refers to the shape of the base. So if we hear or read that we have a hexagonal pyramid, then all that tells us is that we have a hexagon at the bottom and it goes up to a point at the top. And so the nice thing is if we're going to work with these shapes, that the volume formula is always the same. Okay, and what it is we take the area of the base, whatever that shape is. We hope that it's a rectangle or a square because that's really easy to work with, base times height. Okay, but sometimes we get more difficult shapes, and if we can find, even a hexagon or an octagon, don't be scared of those bigger, more complicated shapes. If we can find the area of that base and we can multiply it by the lateral height here, h. Okay, notice that's straight up and down from the apex all the way down to the center of the polygon at the bottom. We can take those two and we can multiply them, and then at the very end we divide by 3 because it comes to a point. So let's try an example then and just work through this, and let's go with a tougher problem because I'm going to assume that you can find the area of the base if the base is a rectangle. Okay, so what's the volume of a hexagonal pyramid, the one you see here? What if it has a side length of 9 and it has a vertical height of 12? Okay, well, in this volume formula, h is going to be really simple. That's 12. But a is going to give us some problems. So we're going to have to spend a little bit of time working on that. And if we can solve for a, then we can plug it back into this formula, multiply it times 12, divide by 3, and we'll have our answer. Okay, so hexagonal base, we would look back at this, then PLTW formula sheet, we'd say, okay, this is a regular polygon. They give us this long complicated formula. It looks like F there is related to this circle that's inscribed inside of the polygon. I don't know. I mean, I don't see anything with an F in it in this case, so we probably don't want to use that. Okay, there is no F, so let's don't use that formula. Let's collapse it down and just use the ns squared over 4 tangent 180 over n. Okay, so in this case, n is the number of sides. It's a hexagon, so n is going to be replaced by the number 6, and s is the side length, and in this case we can see it's a 9. Okay, so let's go plug in 6 for n, 9 for s. We would end up with this. Okay, 6 times 9 squared over 4 times the tangent of 180 over 6. We can do a couple of things here. We can square the 9, and we can also divide 180 by 6. So that gives us 6 times 81 on the top. That gives us 4 times the tangent of 30 on the bottom. Now, our calculators, if we have our calculator in degrees mode, when we type in the tangent of 30, we're going to get 0.577. Okay, so 0.577 is tangent of 30. We have 4 times that on the bottom. And on the top, we just simply took 6 times 81. So I'm doing both of those steps at once. Now, back to the bottom, 4 times 0.577 gives us 2.309. We take 46 and we divide it by 2.309. That gives us an area of the hexagon at the bottom as 210.44. Okay, all of that work was just to find the area of the hexagon. We have not found the volume of the pyramid yet. But what's nice is we can come back to this formula. Now that we know that's 210.44, we can come back here and we can say, aha, I know A. So let's plug in for A. Let's plug in 210.44. 12 is the vertical height. 3 is on the bottom, is just a 3. So I take the top two numbers. If it was me, I just multiply them together. 210 times 12 is 2525. I divide that 3 out at the very end, and I am with the volume of 841.78 cubic inches. Okay, volumes are cubic inches in this case. So hopefully that makes sense. That would be the one process, and we just walk through it with a complicated shape. You know, a hexagon is not an easy shape to do because of that big old formula for the area of the base. If you get, again, a square or a rectangle, that's really simple. Multiply times the height, the area of that times the height, and then divide by 3. That's working with pyramids. Hopefully this makes sense. If you got any questions, please don't hesitate to ask.